Hey there, folks. Mike Rowe here, ready to dig into the nitty-gritty of granular materials. Sand, gravel, and crushed rock form the backbone of our built environment. From roads to buildings, these materials are essential. Civil engineers rely on them for safe, durable infrastructure. Understanding their properties is crucial. Granular materials are like baking ingredients. Their strength and drainage capabilities are vital. They provide stability and proper drainage. Appreciate these unsung heroes next time you drive or walk. Now, let's get our hands dirty and delve into what makes granular materials tick. Two key factors that heavily influence their performance are shape and size. Think of it like a puzzle. The shape and size of each piece dictate how well they fit together and how strong the overall structure will be. Angular particles, with their rough edges and jagged surfaces, are like the pieces with lots of knobs and holes. They interlock tightly, creating a strong bond and resisting movement. Rounded particles, on the other hand, are like the smoother pieces. They don't grip each other as well, resulting in a weaker structure. Size distribution is another critical factor. Imagine trying to build a solid wall with only large stones. You'd have huge gaps, right? That's where smaller particles come in. A well-graded granular material includes a mix of sizes, allowing for tighter packing and a denser, more stable structure. Understanding these characteristics is like having a superpower for civil engineers. By carefully selecting and combining granular materials based on their shape and size, they can fine-tune their properties to meet specific project requirements. It's all about finding the perfect balance for optimal performance. Let's talk about the glue that holds these granular materials together. That's where the distinction between bonded and unbound materials comes in. Bonded materials use a binding agent, like mortar, to create a cohesive mass. Cement and asphalt act like glue, holding particles together. This results in stronger materials, ideal for highways and runways. Unbound materials rely on friction and interlocking for stability. They offer excellent drainage and flexibility. Engineers weigh strength, flexibility, drainage, and cost to choose the best material. Section 4. Compaction, the key to unlocking performance. Imagine building a sandcastle on the beach. You wouldn't just loosely pile up the sand, would you? You'd compact it, squeezing out the air and creating a denser, more stable structure. The same principle applies to granular materials in construction. Compaction is the process of densifying these materials by applying mechanical energy. It's like giving them a good workout, forcing the particles closer together and increasing their contact points. This results in improved strength, reduced settlement, and enhanced load-bearing capacity. Moisture content plays a crucial role in this process. Too little moisture, and the particles won't bind effectively. Too much, and it creates a lubricating effect, hindering compaction. Finding that sweet spot, the optimum moisture content, is key to achieving maximum density and unlocking the material's full potential. Civil engineers use specialized equipment like rollers and vibratory plates to achieve the desired level of compaction. It's a delicate dance between force, moisture, and material properties, all orchestrated to create a solid foundation for whatever lies ahead. Section 5. Durability and maintenance, bonded versus unbound. When it comes to the long haul, durability and maintenance are major considerations for any construction project. Bonded and unbound granular materials each have their strengths and weaknesses in these areas. Bonded materials, with their cohesive structure and resistance to weathering, generally offer superior durability. They're less prone to erosion, rutting, and deformation under heavy loads, making them ideal for high-traffic areas and demanding environments. However, they can be susceptible to cracking over time due to shrinkage, thermal stresses, or subbase movement. Unbound materials, while requiring more frequent maintenance, are generally easier and cheaper to repair. They allow for localized fixes without compromising the entire structure's integrity. Their porous nature also facilitates drainage, reducing the risk of water damage and frost heave. Choosing between the two depends on the specific application, budget constraints, and long-term performance expectations. It's a balancing act between upfront costs, maintenance requirements, and the desired lifespan of the structure.